Okay, so for today we're going to be looking to see or test to see if a quadrilateral is a parallelogram. So if I tell you it's a parallelogram, then we can use all the properties that we know to set up equations and then solve. But what happens if I'm just given some generic quadrilateral? How do I know that it is a parallelogram based on the information? There are 5 ways to determine if a quadrilateral is a parallelogram. Obviously, the first is the definition of parallelogram. So if you can prove, and don't get all excited about the word prove, if you can prove that both pairs of opposite sides are parallel, then it's a parallelogram. So if somehow you can prove or show that these opposite sides are parallel and the other pair is parallel, then yes, you can state it's a parallelogram. The second way is if you can show or prove that both pairs of opposite angles, let's do sides, opposite sides are congruent, then it's a parallelogram. So let's say you have some quadrilateral. If you can somehow prove that these sides are congruent and these sides are congruent to each other, then you can say it's a parallelogram. The third one, if you can prove, that diagonals bisect each other, then it's a parallelogram. So if you can somehow prove that these pieces are congruent and these pieces are congruent, or you can prove that they share the same midpoint, then you can prove that this quadrilateral is a parallelogram. There are 2 other ones. Generally, when we are talking about proving, we're using the coordinate plane and using coordinates. There are 2 other tests that you can use. We are not going to use them as far as when we are using the coordinate plane because we can't. And that is, actually there's another we can. Yes, we can. Number 4, we can. It is if one pair of sides is both, that's a key word, so one pair is both congruent and parallel, then it's a parallelogram. So if I can prove that maybe these are congruent and this same pair of sides are also parallel, then it's a parallelogram. The reason why I'm kind of hesitant on giving you number 5, and I'm going to squeeze it in here, this is because we can't do this with coordinates, and that is if both pairs of opposite angles are congruent, then it's a parallelogram. Okay, so I kind of squeezed number 5 in there. But we have no way using coordinates at this point of finding angle measure. So we're going to be focusing on these 4. Okay, so we're going to be focusing on these 4. So we're going to go back and talk about how would we prove, or what would we have to use in order to prove lines are parallel. Let's see if I can get this back in autofocus. Okay, so how are we going to prove lines are parallel? Well, this goes back to slope. So yes, we are going to be using the slope formula of m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. If we are looking for congruency, that means we're looking for this length being this same length, and then this being the same length as this one. So we would be using the distance formula for this, which is d equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. All of that underneath the square root sign. And then if we are proving that the diagonals bisect each other, in other words, if they share or have the same midpoint, we're going to use the midpoint formula. So that is capital M equals, remember it's a big ordered pair, of x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. And then finally on this one, if we're looking for both congruent and parallel, we'd be using both the distance for the congruency piece and also the slope formula. Okay, so we are going to start off with an example. I'm going to zoom in here a little bit more so I can show you how these are going to be used with ordered pairs. So I have quadrilateral. Let's do quadrilateral ABCD. And we know that A is the ordered pair of -2, 3. B is the ordered pair of -5 and 7. C is the ordered pair of 3, 6. And D is the ordered pair of 6, 2. Okay, at the very beginning, I don't know, I always kind of draw mine to look like a parallelogram. I do not actually graph it. This is not about graphing it. It is about using the math and the formulas in order to prove that it is or is not a quadrilateral. So what I like to do is put my ordered pairs right on my diagram and not just the point. That way I make sure that I'm using the correct ordered pairs. And remember also I talked about that if it says quadrilateral ABCD, you put A somewhere and then you have to go consecutively. You can't go and be bouncing and putting your letters wherever you want because it does make a difference. Okay, so if I want to prove this is a quadrilateral, remember I have a couple different ways. I can prove that both pairs of opposite sides are parallel. I'm going to kind of just abbreviate this. Okay, so if I showed or tried to prove that both pairs of sides are parallel, I would be using the slope formula 1, 2, 3, 4 times. And I'd be checking to make sure that these two lines have the same slope and these two have the same slope. So here are my choices. I can use both pairs of opposite sides by using the slope formula times 4. I have to use it 4 times. Or I can prove that both pairs of opposite sides are congruent. These are just possible ways that I could do this. I could show that both pairs sides are congruent. So that means I would have to use the distance formula four times, once for each side. Or I could prove that the diagonals bisect each other. So that means I'd have to use the midpoint formula twice. Or I could find that I have one pair of sides congruent and parallel. So that means that I have to use the distance formula twice, once for each line. So distance twice, so distance times 2, and the slope formula times 2. Well, I don't know about you, but using this 4 times, and 4 total things here, I'm probably more apt to lean to that one. And when we start proving rectangles and squares and rhombi and trapezoids, I would say 99% of the time I am going to use the diagonals because I have 2 diagonals versus 4 sides. So I am going to show that the diagonals bisect each other. So I'm going to use the midpoint formula twice. So my diagonal consists of AC. Make sure that when you are showing your work that you are very clear on what segment is you're doing. That way I don't have 4 distance formulas and I have no idea what formula goes to what side. So make sure you're very clear in your label. So AC, midpoint of AC would be -2 plus 3 divided by 2, and 3 plus 6 divided by 2 gives me 1/2, and there's 9 halves. So I can say that the midpoint of AC is 1/2, and let's say 4 halves, or 4.5. Okay? Now I need to do my other diagonal, which is DB or BD. So I have 6 minus 5, remember this is a big ordered pair, divided by 2, and 2 plus 7 divided by 2 gives me 1/2. And there's my 9 halves again. So BD is also 1/2, and let's say 4.5. So your work is important, but don't forget how to explain this to your teacher. So I can say that quadrilateral ABCD is a parallelogram because, this is the important piece, the diagonals have the same midpoint. Okay? I'm going to go ahead and do another video showing some other methods. So we'll call this next video a part 2.